So I have a small dish here that's just got water in it. That's all. Okay? And then we're going to have some sodium here. And we're going to react, and we're going to put the sodium in the water. So you have a list of an activity series, okay? And you have to read the activity series and make a prediction about what's going to happen. Now, be careful on your activity series because there's more information than just the columns of elements, okay? There's information about reactions over here on the right-hand side and how they react, okay? Over here. Okay? Look what it says right up here in the right-hand corner on that activity series. Okay? All right. In Unit 2, we looked at a periodic table in which we showed a pattern of reactivity. We showed a pattern of reactivity. And what I explained at that time was the elements in column 1 tend to be the most reactive on the left-hand side. The elements in column 7A tend to be most reactive on the right-hand side. And that you can define reactivity in different ways, okay? But that sodium, when you put everything together, is one of the most reactive elements in the periodic table, and that's what we're going to be working with here, okay? So I have inside this little bottle some little chunks of sodium. Notice I'm not touching it with my hands, okay? So there's just a little chunk of sodium. Now, with the lights dim like this, what you can't see so well is that sodium has a white coating on it. All right? Okay, it's got a white coating on it. That's the oxidation from the sodium. And in order to see the shiny metal, I want to cut this little piece in two so you can see the shiny metal itself without the oxidation on it. Okay? That's a very soft metal, so I can just cut it with a knife. Okay? And now you can see that there's a shiny inside.
Not really.
Yeah, I can't see.
Where that spot is, move over to the right.
Because it's like reflecting the camera.
Yeah.
You see it? It's like a blue.
That little blue circle. You move it up a little bit. There you go.
Okay? All right. So I want to take and put this back in my bottle and safely put it away. Okay, has everybody made their prediction? You think you know what's going to happen?
Is this something that should be in our lab notebook? Or is this
I said to put it in your lab notebook. Okay. All right, you ready? Everybody watching?
Doing just what the thing said.
fire.
right?
Explode.
Fire.
Okay.
Why you jumping?
About
Because
to
I
water
see my
and
dude, he gets
throw
me.
it in the creek.
See?
What happened?
You know what happened? It's gone.
Why everybody jump?
Because he said, boom.
Or let's just water.
Just water and sodium metal.
It reacted with
Can
the
you buy
water.
sodium metal anywhere?
No, you cannot.
Crap. How you get this? They're gonna burn in the snake.
He's not teaching clothes.
We got snakes in the creek. Don't want to get creek.
Okay, let's talk about what you're going to be doing in the lab now.
Was that sodium metal?
That was sodium metal. All right. On your lab tables, when you get back there, you've got a basket that contains one of these well plates. Okay? And so you're going to run your reactions in these well plates. We're going to be good stewards of the environment. We're going to take care of the environment by only using small amounts and only enough to do what we need to do for our observations. Okay? And you're going to have a chart in each basket or on the lab table that looks something like this, and this is designed to show you how you're going to put this together. So if you lay this on there, it's kind of a template for you to see how you're putting it together. So you're going to have zinc in the wells in this row, and silver in the cells or the wells in this row, and then you're going to put the solutions in these columns. Okay? No, you're supposed to draw a chart last night, not this.
Yeah, but
He's saying there's no word,
Okay, there is a chart you were supposed to do in your lab notebook, but that was on the handout from yesterday. Now on the other side of this handout that's in your, on the lab tables, guys, I really kind of need your attention up here, is this template. Now this one's blank. It'll make it easier for you to see the reactions if you put it on top of there. You still have the arrow showing what metals go in these wells and what solutions go in the wells. It'll be on the lab tables, and you've got the sheets in a plastic wrapper, and you flip it over. It's one side or the other. You can that hopefully give you enough information you can figure out what you're doing. And so when you put your metals in there, you're only going to use very small amounts of metal. You don't need a lot. If they're not already cut up for you, do not use, if there are sheets of metals that can be cut with scissors, do not use pieces of metal that are larger than 3 millimeters. 3 millimeters. So those little tiny markings here, right there, those are millimeters. So when I say no larger than 3 millimeters, I mean a square that's no larger than that right there on each side. You don't need but little bitty pieces. Okay? Some of the materials you're using, some of the metals you're using come in what are called shavings, and you're just going to take a little bit of it and kind of ball it up and drop it in there. But you don't need a lot. And then whenever you are ready to put your solutions in, so you're putting the metals in first and then the solutions, and then you're only going to put enough of your solutions in there to just barely cover the metal. That's all you need. And that way we don't use more chemicals than we have to use. It's kind of a micro lab here. But then you have to look very carefully and watch for evidence of a reaction. Okay, does that make sense? Okay, it's a really simple lab. The only thing I want you to be careful about is one of the things we are working with is hydrochloric acid over here. It's not really concentrated, but could cause some problems, so be careful with that. When you are done, I put up a moment ago some instructions about how to handle the cleanup. I want to keep any unreacted metals. Okay, metals that don't react in here, you're going to use some forceps, which are basically tweezers, like I used for the sodium a moment ago, and pull out those unreacted metals, rinse them off, dry them on a paper towel, and put them back in the baggie they came from. Does that make sense?
Like for the cube, not for the shaving.
Whatever's not reactive, just put them back in there. Okay? Yes? Can you have some whiteout? You don't put whiteout in a lab notebook. In a lab notebook, you draw a line through any mistakes and write it over. Okay? You're not supposed to scratch things out or white things out or erase things in a lab notebook.
I mean, I have a habit of scratching.
I know, but I want you to try to get out of that habit and use just simply a single line across the mistake. Okay? One of the things you need to make sure is all of your metals are shiny, like I made the side of that sodium shiny. Okay? And in your basket on every lab table is some, you might call it sandpaper. It's actually called emery cloth. And if you need to sand it off, you can do that. But please don't lay it flat on the lab table and sand across it and put scratches on the lab table, okay? You've got a pair of pliers back there. You can lay it on top of a paper towel or something, but let's don't scratch up the lab table if we don't have to. Fair enough? All right, now, whenever you run your reaction, you only need enough liquid to cover, just barely cover, whatever your metal is, okay? We don't want to waste material if we don't have to. we're going to be good stewards of the environment and not use more material than we have to.